All right, section 2.3, we're skipping the section on circles, so we're going on to section 2.3, which is about functions and relations. We've talked about functions for several years now, so hopefully this is again pretty familiar. Determine whether or not a relation is a function, apply function notation, determine x and y intercepts of a function defined by y equals f of x, determine the domain and range of a function, and interpret a function graphically. A set of ordered pairs, any set of ordered pairs, x, y, is a relation in x and y. It could be a relation in a and b, and that's how you would say that. That's the words you would use. The set of x values in the ordered pairs is the domain of the relation. The set of y values in the ordered pairs is the range of the relation. And you've heard of domain and range a lot. Okay. For the table shown, write the set of ordered pairs that defines the relation, write the domain, and write the range. Okay, so the set of ordered pairs, again, you're going to use set notation, so you're going to use brackets, and it would be 3, -4, and then it would be -2, 0, 5, 3, and 1, 0. Okay, and that is the set of ordered pairs. There's 4 of them. The domain, you usually list it from least to greatest. So it would be -2, 1, 3, and 5. And if it's just a set of points, then your domain is a list. If it's a line where it's everything between, it's, then it's not a list. It's a function, or it's an equation, or it's an inequality. So this is the domain. It's all the x's. And the range then is going to be your lowest number, which is -4, then 0, and then 3. And notice the 0 occurred twice, but I only listed it once. So when you list your domain and range, don't list them more than one time, and list them preferably from least to greatest. Okay. Given a relation in x and y, we say that y is a function of x if, for each value of x in the domain, there is exactly one value of y in the range. And basically that means there's no repeating x values. The y's can repeat, but not the x's. So is this a function? Determine if the relation defines y as a function of x. Well, you look and you see no, because we've got 2 x's that are the same right there, 2 2's. So different y's, but it doesn't matter. It matters that the x's are the same. So no, it's not a function. Looking at this one, we have all different x's. We do have some of the y's the same, but it doesn't matter. So looking here at these examples, we've got, looking only at the x's, we've got an 8, a 3, and a 5 in A. So in A, yes, that one's a function. In B, we've got 2 -3's. We've got a -3 there and a -3 there. So no, that is not a function. Determine if the relation defines y as a function of x. You notice every x goes over to one y, and there's no x's that are the same. So that is a function. Determine if the relation defines y as a function of x. Well, this one's a little harder because it's not a set of points, is it? It is. It's a linear function. Y equals 2x plus 6. What about 5? Y equals 2x squared plus 6. Yes, that's also a function. It's a quadratic function. Now, you may have to graph them to see these things. Determine if the relation defines y as a function of x. Y is equal to 7 minus x. So yes, it's a function. X equals 7 minus y squared. Y squared is equal to 7 minus x. And so then here we have y equals plus or minus 7 minus x. And that plus or minus is going to say, no, it's not a function, because all the values will not be unique. So if you see a y squared, it's not going to be a function. Y cubed, cube root is unique. The cube is a function. And so some of this you might have to put in your graphing calculator, and you're going to use the vertical line test preferentially to decide. A graph defines y as a function of x if no vertical line intersects the graph in more than one point. And so it's easier really with equations to look at the graph, unless you just know that a quadratic is always a function. A cube is a function. Now, quadratic, if the x is what's squared. If it's the y that's squared, remember that was the sideways parabola, and that one was not a function. Okay, determine if the graph defines y as a function of x. Again, you're going to look at your vertical line test. You see those lines, and it crosses, the blue graph crosses the red line in more than one place, so no, it's not a function. 10, draw some vertical lines. Never crosses more than one time, so yes, that is a function. And this one is a little trickier, but you see right there on the axis, there's two values. It's a split, it's a piecewise function, which we'll talk about at some point, but it doesn't, there's two solid circles, so that means there's two points that have the same x value. If it had been like that, where one was open and one was closed, then it would have been a function. Okay, so A is not a function. B is a function. C is not a function because of the two closed circles on the -2. Okay, determine if the relation defines y as a function of x. They all go to the same y in A, but it is a function because all the x's are different. B is a sideways V, so that is not a function. And C is a circle, so that is not a function. Apply function notation. F of x is equal to 2x squared minus 3x plus 1 for given values of x. Or you could say y equals 2x squared minus 3x plus 1. F of -3 means that you're going to put a -3 in for all the x's. And it basically is asking, what is y when x is -3? So you put a -3 in there, and you get an answer. And y is 28. So you'd have a point on the graph would be -3, 28. For B, what is y when x is -2? So you put -2 in for all the x's, and you come out with 5 minus 3 times the square root of 2. Well, you can also do an A. Put an A in for all the x's. Well, you still end up with an equation, but that is f of A means you replace all your x's with whatever's in the parentheses. Now, 3 plus z is harder because you've got 2 times 3 plus z squared, which you're going to have to then square that binomial, minus 3 times 3 plus z plus 1. So then you have to multiply everything out, and 3 plus z multiplies out to be 9 plus 6z plus z squared. Then distributing the -3, you have minus 9 minus 3z and plus 1. You're going to have to multiply 2 by all the first parentheses. Combine all any z squareds, any z's, and any constants to get a trinomial, and you end up with 2z squared plus 9z plus 10. So that one's harder. Okay, evaluate g of x is equal to 6 minus 2x for the given value. So g of 3, 6 minus 2 times 3, or 0. G of 4, 6 minus 2 times 4, square root of -2, or I. You could say I times the square root of 2, or undefined. G of -4, 6 minus 2 times negative 4, which is 6 plus 8, or the square root of 14. G of 2w, 6 minus 2 times 2w, 6 minus 4w. Okay, so hopefully you can plug these in and get answers. These all look pretty straightforward. Let me do B here for you because that one's the one that's a little tricky. We have our basic function. We have m of x is equal to negative x squared plus 4x. And you want m of a plus h. So that's going to be negative a plus h squared plus 4 times a plus h. So let's go down here at the bottom and look and see how a plus h is going to be when we square it. So we just double distribute, and so you're going to have a squared plus ah, then we're going to distribute here, plus another ah, even though it's ha, ha is the same thing, plus h squared. So these are going to add up to be 2ah. So when we go back up to the top here, we're going to have negative a squared plus 2ah plus h squared plus 4a plus 4h. All right, then this is going to be negative a squared minus 2ah minus h squared plus 4a plus 4h. And there's actually nothing there that we can add and subtract. So our final answer, excuse my coughing, is all of that. There's nothing I can combine to make it any simpler. Sad but true. That's the answer. Okay. Determine x and y intercepts of a function defined by y equals f of x. So given this function, the x-intercepts where y equals 0, f of x equals 0, and the y-intercept is given by f of 0. In other words, x is 0. So find the x and y-intercepts. Again, for the x-intercept, y equals 0, so x squared minus 4 equals 0. X squared equals 4, x is equal to plus or minus 2, which is two distinct points, 2, 0 and negative 2, 0. The y-intercept, you're going to make the x equal 0. F of 0 is equal to 0 minus 4, which is negative 4. So the point is 0, negative 4. G of x is equal to 3 minus absolute value of x. For the x-intercept, it's 3 minus absolute value of x equals 0. 3 is equal to absolute value of x, which would be plus or minus 3. For the y-intercept, you look at g of 0, so 3 minus absolute value of 0 is 3. Okay, x-intercept, 2 minus the square root of x equals 0. Square root of x equals 2. Square both sides, x equals 4. So you have 4, 0. Again, for the x-intercept, y is always 0. For the y-intercept, you have 2 minus the square root of 0, which is 0. So 0, 2. So find this x and y intercept. So really, I like to think about this in many ways as y equals the absolute value of x minus 5. So I'm looking for the x-intercept. So that means y is equal to 0. So 0 equals the absolute value of x minus 5. So the absolute value of x equals 5. And remember, with absolute values, you set up two equations, one positive, one negative. So x is equal to 5 and x is equal to negative 5, which are the points 5, 0 and negative 5, 0. Okay, so that's that one. Now for the y-intercept, you make your x equal 0. All right, so I have y equals absolute value of 0 minus 5, absolute value of 0, 0. Y equals negative 5. Excuse me, so it's negative 5. Excuse me. Erase that. It's 0, negative 5 for the y-intercept. All right, domain and range, you have to look. And sometimes some of these are a little tricky. For all quadratics, the domain is negative infinity to positive infinity because those arrows are always going out, up and out. There is a range limitation. There's nothing below, in this case, the 2. The y, we're looking at the y value. So from 2 to infinity, we've got a graph. So square bracket 2 to infinity is the range for this particular function. Looking at this one, we've got arrows on both sides. So that means it's going from negative infinity to positive infinity. The highest value of the y, or the range, is going up with arrows, so it's going to go to infinity. But there is a low value. The low value looks like it's at negative 10. Then you have to look where there's that jump with the two graphs. And if you notice there, we have a closed circle and an open circle. So that is included where there's the closed circle. So there's not really a gap in the range or a gap in the domain, but there is a gap in the graph in terms of there's two different graphs. But the range then is from negative 10, including negative 10, all the way up to infinity. Okay, again, we have open circle, closed circle situation. We have an endpoint on the right, and we have an arrow on the left. So we're going to go from negative infinity on the left. We continue all the way through to 4, and it includes 4. The range is going to go from 1. Now, there is a gap between 1 and 2. So how are you going to go? How are you going to do that? So let's look. It's 1. Okay. Really, I would have put square brackets around the 1. It's 1 union 2 to 8. Again, we're looking at the y values. All right, this one. This is a strange little graph. You have an endpoint on the left, but you've got this downward turn, and there's an arrow at the end of that. So in terms of the x, it's going to go from negative 2 to infinity. We can't see that that's turned down. As far as we know, it's going to keep edging out. What about the range? That arrow pointing down means it goes down, 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 down. So it's negative infinity to the high point on the graph, which looks like it's 4, and it would include 4. All right, so when we have points like A, you're going to list them. If it's a set of points, like you see there on A, you're going to list the set. So your x's are at negative 4, negative 2, 0, 3, and 4. Okay, that's your domain. Your range is going to be at negative 3, 0, 1, and 5. Okay. Now looking at B, we've got an endpoint, we've got negative infinity. Your domain is going to go from negative infinity, and it goes without any breaks to 4. and your range, the low value is at -4. I don't think that's a square bracket. And it goes, an arrow means it's going to go up, so it's going to go up to infinity. Write the domain of each in interval notation. Tricky. A is tricky. Remember, denominator can't be 0, so when we're looking at A, here, we need to figure out 3x plus 1 equals 0. 3x equals -1, x equals -1/3. So x can't be -1/3. It can be anything else, but -1/3 is going to make the denominator 0 for A. So the way you're going to do that is -infinity to -1/3. Not going to include -1/3, union -1/3 to infinity. Everything except -1/3. B, that's -infinity to +infinity. It's a quadratic, it's all real. That 1/5 doesn't, the divided by 5 doesn't change that. It just makes it a real broad graph. C is a square root function. So I'm going to go ahead and put C here. Okay, we can't have a square root that's the lowest thing in the square root. We need to set that equal to 0 also. So x can't be any lower than -3. If it's below that, it's going to make a negative number under the radical. So that means it's going to go from -3 to infinity. It can't be any lower than -3, because if it is, again, that's going to make what's under that radical a negative number. It can be 0, but it can't be negative. And D is a parabola, and so it's going to be -infinity to +infinity. It's next squared. Okay. Interpret a function graphically. So here's a graph. What is f of -3? So you're going to go over, that means what is y when x is -3? So you're going to go over here, 1, 2, 3, and read down. And that's what your value is over here when x is -3. Okay? So it's going to be -3. When f is 0, what is y when x is 0? It's going to be 2. Okay, if you're not sure, when we've got 0, we go up here and read, and there's your point that you're looking for at 2. Okay, find all x's for which f of x is -1. Find all x's for which f of x equals 1. So in other words, find all the x's for which y is equal to -1. Okay, so where is y equal to -1? Right here. So the x value would be 1, right? Where is y equal 1? Okay, it looks like it could be here, but remember that's an open circle, so it's not. It's just here at 2. So 1 and a 2. Determine the x-intercept. Does it cross the x-axis anywhere? No, there is none. Determine the y-intercept. Where does it cross the y-axis? At 0, 2. Determine the domain of f. There's arrows on both ends, so it's going to be -infinity to +infinity. Looking at going sideways. The range up and down, there's a gap. It goes from -infinity to -1. Okay, then it unions with 1 to infinity. Now, why is that 1 included and not, we have an open circle here, so why is 1 included? Because of right here. Okay, because it touches right there. So that's why the 1 is included with a square bracket. So you have to be careful on some of these. Use the function pictured to find. Let's see if we can do this real quickly because I know we're... Okay, f of -2. At -2, what is y? I'll just write it beside, go here. At -2, right here, y is 1. At 4, here, there is no y because it's an open circle. Okay, so there's no solution there. All x's for which y is equal to 3. So here's y is equal to 3, so it's going to be -4. And you need to put x equals -4. I'm going through this pretty fast. All x's for which y is equal to 1. Well, it's everything from -3 to -1. So that's going to be -3 to -1, like that, because it's everything in between. It's not just -3, -2, and -1. It's everything in between, all the fractions and decimals. X-intercept is at 0, 0. Y-intercept is also at 0, 0. The domain of f, x is -infinity to 4, but it doesn't include 4. And the range is from -4, but it doesn't include that, to positive infinity, like that. Okay.